This training module will introduce you to the technical principles of the basic transmitter. The secondary electronic unit, called the communication board, is enclosed in a housing which contains the terminal block for the electrical connections and often a display. The most common material used for the housing is aluminium alloy, but it can also be stainless steel, plastic, or other special materials. Depending on the application requirements, the electronics can be intrinsically safe and/or the housing can be explosion-proof. Intrinsically safe means that whatever happens, there will be not enough energy to ignite a fire, whereas explosion-proof means that even if an explosion takes place inside the instrument, flames do not exit the instrument housing. As mentioned before, the communication board is an essential part of the transmitter, since it converts the signal according to a specific protocol, chosen by the customer according to its own control system. Heart, Profibus, Foundation Field Bus, and Modbus. Definition. A diaphragm seals assembly consists of an appropriate process connection, a stem, and a diaphragm connected through a capillary of variable length to the transmitter body, which acts as an interface between the process and the instrument. In a standard application, the installer uses dedicated pipes to connect the transmitter to the process. These pipes are called impulse lines. When this is not possible or recommendable, it is necessary to install the so-called diaphragm seals, isolating diaphragms that act as an interface between the process and the transmitter. Diaphragm seals are to be used when the process fluid is highly corrosive, dirty, solid-laden, or viscous, and could foul the impulse line. The process fluid can solidify inside the impulse line or inside the transmitter body because of temperature decreasing. The transmitter is located in a hazardous area or must be located away from the process. The process temperature exceeds the maximum limits for the transmitter. The required impulse line length becomes impracticable for the installation. Manufacturing process. Once connected to the individual components, the air is evacuated. The assembly is filled with an incompressible fluid, and at the end, the sealed system is welded. Functioning principle. When process pressure is applied to the seal diaphragm, this deflects and exerts a force against the fill fluid. Since the liquid is incompressible, the same level of force is transmitted hydraulically to the transmitter body, which similarly transmits the pressure to the sensor, which acts as described at the beginning of this e-learning module. Most manufacturers, with the exception of ABB, use gaskets within the remote seal construction. Gaskets are a weakness in the remote seal system because due to temperature and pressure changes, air molecules can enter the hydraulic circuit and affect the measurement, causing serious and irreparable errors. In addition, since the errors develop slowly, it is difficult to detect them immediately when they arise. Therefore, the plant may work under suboptimal conditions without any warning. Primary isolation diaphragm, welding capillary, filling capillary, capillary seal, element stem, element flange, seal diaphragm, welded, weld ring gasket surface. Diaphragm seals allow differential, gauge, or absolute pressure measurements. Seals can be connected as follows. Directly mounted, with a short capillary connecting the integral seal to the transmitter sensor. Through a capillary system which links the transmitter sensor to a remote seal of any version. For remote seal applications, the transmitter can be selected with 2 seals using the same fill fluid, capillary, and diaphragm size. One seal having the other side configured with a process flange for wet-dry leg connection, or a blind flange providing vacuum or atmospheric reference. As explained before, the response time is the period between the change of the physical variable and the corresponding reading on the instrument. The response time of a transmitter can be significantly increased when connected to a remote seal due to the total length of capillary connecting the seal element to the transmitter body. The response time is directly proportional to the length of capillary. Therefore, the length of capillary has to be minimized, provided that the application requirements are satisfied. The inside diameter of the capillary. The response time of the instrument is inversely proportional to the fourth power of the capillary diameter. A smaller capillary section therefore delays the response. The fluid viscosity. It is intuitive that a high viscosity of the fluid increases the time it will take that fluid to transmit an applied force through the system. Also, the temperature effect on viscosity, generally the viscosity increases as temperature decreases, has to be considered. In particular, the temperature along the length of the capillary is important. The lower this average temperature, the slower the response time of the system. Temperature error. A change in temperature from the one at which the system was calibrated, called reference temperature, will cause the fill fluid to expand or contract. The change in volume causes the internal pressure of the system to change. This will in turn generate a deflection in the diaphragm, which leads to zero shifts and unwanted measurement errors. After installation, this effect can be zeroed out. However, each time there's a temperature variation in the process or ambient temperature which affects the temperature of one or more components of the remote seal, a measurement error will be induced. To minimize the impact of temperature effect, a differential pressure measurement with two remote seals that have the same dimensions, including the capillary length, can be applied. If the temperature of both branches of the transmitter is the same, the effect on the differential pressure transmitter equipped with a balanced diaphragm seal system will be self-compensated, minimizing the error. Other aspects and features that minimize the temperature errors are reduced amount of oil, that is, shorter capillaries, or lower diaphragm spring rates, more flexible. In order to disconnect the transmitter from the process, it's necessary to use a device called manifold that isolates the transmitter from the process. Manifolds consist of a steel body with internal connections and valves that stop the access of the process fluid to the transmitter, connect the transmitter to atmosphere, connect between the impulse lines. Depending on the type of the transmitter, gauge or differential, and measurements, manifolds with 2, 3, or 5 ways can be used. Okay, you've seen a lot of facts and information, and I'm sure a lot of it is not new to you. So, what have you learned so far? The top works are essential as they include power supply connections as well as all communication capabilities. Diaphragm seal design, manufacturing process, functions. Possible configurations and main seal related errors. Manifold working principles and functions.